Okay, so the process according to which a neural network makes its predictions is called forward propagation. So let us look at this forward propagation one more time. So in this case, notice that the input is four-dimensional, right? So our input belongs to R4. When this input goes into layer 2, which is the first hidden layer, what we do, we first apply a linear transformation to this input. So basically, we can write it like this, like what you see on the screen. So like the product of a 2x5 matrix and 5x1 matrix, where the 5x1 matrix is made out of the initial 4x1 input with just by augmenting it with 1. Or we can also write it differently. So we can write this as B1 plus W1 times X, where our X is the 4 times 1 input matrix. Our W1 is 2 times 4. Yeah, and this 4 is basically P, and this 2 is the number of neurons in our layer 2. And this 2 is B should be also 2 by 1 to make matrix dimensions consistent. So this is B, and this is W. This B is also called a bias vector. And this W, so it's also called the weight matrix. Weight matrix. All right. Now, after we have computed this this Z vector, so the next stage is to apply some nonlinear function to every entry of this Z vector, right? So in this case, we are applying R, so which is the ReLU or rectifier. So this is R is ReLU. So remember that ReLU looks like this. So if this is Z, this is say R, so then my ReLU function looks like 0 here and Z here. Yeah, in practice, dimensions of these matrices can be extremely large, but these are very efficient operations, so we shouldn't worry too much about it. Okay, in layer 3, so whatever input in layer 3 is, it is the output of layer 2, right? So we can also, and the output of layer 2 is two-dimensional, so which is why the input of layer 3 is again two-dimensional, and then it depends on how we represent it. So we can either split it in two, like B2 and W2, and rewrite it as B2 plus W2 times A2, and this is going to be a 2 by 1 matrix. This is 3 by 2, and this is 3 by 1. Or we can also combine them together into a single matrix multiplication. It doesn't really matter how you represent it. I'm not even sure how it is done under the hood in R or Python libraries. And then once we computed this Z, we apply our activation, which is the linear rectifier, to every entry of Z, and this is how we calculate A. And this A becomes the output of our layer 3, which is also the input of layer 4, right? So the input of layer 4 is our A3. And then we can, again, do some matrix multiplication. And then we apply an activation, which is, again, the rectifier. And then finally, we have our layer 5, which is the output, right? So then we do the same thing. So we apply a linear transformation to the input. But now, since this is our output layer and our output, we want to do a classification. So our output should be just a single number, single scalar that tells us the probability of whatever it is. So it should be a number between 0 and 1, right? So once we computed this Z5, then we apply an activation in the output layer. And the activation in the output layer is the sigmoid. Well, and then the total number of parameters is 30, right? So parameters are these weights, and the so-called biases. Okay, so here is a little quiz after this part about forward propagation.